Hello, this is the continuation of the previous class. So if you haven't watched the previous class, please watch it and understand the basics of how to install SPSS and how to enter data into the SPSS file. So in the introduction, we were talking about how to feed data into the SPSS file. This time we want now to analyze this data that we fed into the SPSS file. We want to conduct tests to it so that we can determine the association or the hypothesis tests. We want to check for normality, we want to check for descriptive statistics, we want to check for other linear correlation coefficients through regression analysis. Therefore, welcome. And if you haven't watched the previous video, please watch it. For this one, I also request you to watch, to subscribe, to like, and to share so that we can continue learning together the SPSS. Now, after understanding the basics of SPSS, we have to input this data in the Excel file to the SPSS sheet. And we find that this I already imported as I had explained to you earlier. So we have the ID, this is the ID. We have higher education, and also here is there's higher education. Then there is whether the ethnicity is black, whether they are of the mixed ethnicity, the husband and wife are of the same ethnicity or are of the mixed ethnicity, the number of years in marriage, whether they are divorced or they are censored. So we are going to conduct analysis in SPSS, and as I told you earlier, we have to input data in the correct format. So the ID I have changed it to numeric because it is numeric. This higher education is in this section. It is a string, but because I have to analyze it, SPSS only analyzes string numeric values. So I have to change it to numeric, and that is why here in the sections value I have to represent 1 represents less than 12 years, 2 represents 12 to 15 years, while 3 represents more than 16 years. What I did is come in this section and use the if function. If B2 is equals to less than 12 years, it has to be represented by 1. If it is 12 to 15 years, it is represented by 2. Otherwise, it is 3. Similarly, I have to use the if function here to state whether the husband is black or not black. So if the husband is black, if C2 is equals to if the husband is black, we are represented by 1, and if the husband is not black, we are represented by 2. So next is whether they are of the mixed ethnicity. I also use the if function. If they are divorced, I also use the if function. Then I copied this data and entered them as numeric values in the SPSS file, just as I demonstrated on the other side. However, for those that did not attend the previous class, I can do it for you. So I come to File, New Data, then I feed in the variables as it is needed. So I'll copy all this. So this is ID. The data type is numeric. The width we can increase to 10. Let's see if there are any changes. Yes, it is ID, so it is numeric. The next is H, education, whether the husband attended higher education. The data type is it is string, but we have to convert it to numeric for easy analysis. Click OK. So the width is we have to select a higher width because more than 18 has more than so that they fit. The decimals none, and labels is I'll use the duration husband has achieved higher education. The third variable is whether the husband is black. The third is mixed. The third is number of years in marriage. The fourth is divorce status. So this has to be changed to numeric also. Numeric. The width has to be let's say 30. Mixed has to be numeric. Width, let's increase it to 30. The number of years in marriage, the years has to be numeric, and this increased to 30. And the divorce also has to be numeric, and the width increased to, let's say, 30. I'm using 30 because it is the maximum width. The number of characters cannot exceed 30, or if even the characters are 100, you can change the width to 100 characters. By characters, I mean one more than 16 years. So when you count MORE space THAN space 16 space years, all these are the number of characters that have to be within the range that is required. Rather, if you do not choose the number of characters that are needed, will be the extra words beyond the number of characters will be rounded off or rounded up, and they'll be cut off from the other sections of the words. They'll be cut off. So coming back to the data view, you realize that when I was changing this from string to numeric, all the data was deleted. So I have to also change the values. I have to make all the changes before I go to the next. And what I did in Excel is to change so that it is easy for me to realize. So that you realize, and I use the if function. If B2 is less than 12 years, I have to use 1. If it is 12 to 15 years, I use 2. And if it is otherwise, or more than 16 years, then I use 3. So I come to SPSS and make the changes. Higher education. So 1 represents less than 12 years. Then I click add. 2 represents 12 to 15 years. 12 to 15 years. Then I click add. Then 3 represents more than 16 years. Click add and OK. So it has all the values. The next is whether the husband is black. So I have to check what I did input in this. If C2 is equals to yes, I have to use 1. If no, then it is 2. So the next is the next values in this. So 1 is yes, then add, then 2 is no. Click add, then OK. The third is whether the couples are of mixed ethnicity. So 1 is yes, then 2 is no. So 1 is yes, then I add 2 is no. Add, OK. The third is the number of years in marriage. That one will come as the way it is. I'll copy and paste it as the way it is. Then the third is if they divorced, whether they are divorced or censored. So number 1, yes, or number 2, no. So I have to, in the original data set, 1 represents divorced, while 2 represents censored. So I have to make these changes so that it is not either no or yes. So I come to this section and make the changes. So number 1 is divorced. Add. Number 2 is censored. Then I add. Then click OK. So in case I input here 1, you'll see that they are divorced. In case I put here 2, you'll find that they are not of the mixed. They are not of the mixed ethnicity. In case I input here 1, you find that the husband is black. In case I input here 3, it will be more than 16 years. If I have to change here to 5, it will not give me anything because we have no value of 5. It is either yes or no. So you can choose no or yes depending on what your analysis will give you. So I have to copy now this entire dataset and paste it here because we have what it needs. The number of years, we have decimal places, let's say 2. Yeah, we have 2 decimal places because it's 17. In fact, we have 3 decimal places because 16.706, 4.085. So let's use 3 decimal places and click OK so that we have this has shown us the data as it needs to be. Now, what we have to do now is copy the entire data. We have to choose this because this is what is needed to be pasted on the other file. Since this is a string and the sections we are we are pasting, they are not string. So I have to use this to make sure that data is pasting in the right manner. So I'll click this cell. I hold Shift and Control, move to the right and use the down arrow. So I once again copy and go to the SPSS file and click paste, and it pastes all the data that is needed. I've made a mistake. Let me undo this. So I move to this section because we are only picking from we pick from higher education, husband black, mixed ethnicity. IDs were correct, so there's no need of changing them. So I come and paste it here. Then I paste. So you find it has pasted all that is needed. When you change this using this, find that we have all that is needed. When you change to this, you find it is numeric. But when you change to this, you find that we have now the alphanumeric that are needed here. So we move to the next section. We start the analysis. So I have picked this file or this Word document to guide us on the analysis that we're going to conduct on the data. The first analysis on any SPSS for research is conducting the descriptive statistics for the mean, mode, median, standard error, deviation, maximum, and all that is needed for the continuous variables. Then we can conduct frequency analysis for the categorical or the discrete variables, such as yes or no, values that have responses like yes or no, or values with Likert scale data, such as strongly disagree, disagree, neutral, agree, and strongly agree. So we conduct frequency analysis for the discrete data, while we conduct descriptive statistics for the continuous variables. So that is always what we want to do, especially when we have to conduct the demographic data analysis. For example, we have to assess the number of males and the number of females and their proportions. We have to use the frequency analysis. After that, we conduct reliability statistics. Reliability tests are conducted to determine whether there is internal consistency in the data. For example, you may have issued a questionnaire to the respondents, but the respondents did not take keen attention to answer the questions as they are supposed to. So they were picking any value without considering the consistency of what you are analyzing. For example, if you are using Likert scale data and you've classified things into 2 groups or to 3 groups, and you say, for example, does the interest rate increase by the central banks or by the federal banks affect uh, loans or affect how the commercial banks give loans to their clients? So in that research question, you may have about 5 questions. So if the 5 questions have been answered consistently, we will have a high reliability value, so that it indicates that there is internal consistency in the data. If the data is not internally consistent, it means that the research has to be conducted again. The data collection phase has to be conducted again. While if the data is internally consistent, you can progress with your data analysis on research. We also conduct normality tests, that is to check whether the data is normally distributed or not normally distributed. If the data is not normally distributed, we will use the Pearson correlation coefficient to determine whether there's a high correlation between the independent and the dependent variable. While if the data is not normally distributed, we use the Spearman rank correlation. The next tests that we conduct are hypothesis and correlation tests. I classified them together because after conducting the hypothesis tests, especially for the discrete data, uh, SPSS gives you an option to conduct correlation tests. So I conduct them together. So you find whether the independent and the dependent variables have any association. Then after that, now we find the correlation of that or the degree of the association. The hypothesis checks whether there is any association or any dependencies or any association between the independent and the dependent variables. Sometimes there are no associations. but sometimes there are associations. After finding that the dependent and independent variables are associated, we determine the degree of the association or the extent of the association, and that is now the correlation tests. Therefore, correlation tests give us the extent or the degree of the association of the dependent and independent variables. After that, we conduct multiple linear regression tests. This is done on the assumption that the dependent and independent variables are collinearly related, or they have some collinearity. In some cases, we may have a high association because of the hypothesis test shows that we have a high association. However, the regression tests give us somewhat different, showing that they do not have a linear relationship. This is common because let it not surprise you, because sometimes data may be associated to another. However, the relationship can be sinusoidal, can be polynomial, can be quadratic, or can follow any other pattern apart from a linear pattern. Therefore, in most tests that we conduct, we assume that we are going to use a linear pattern. However, the data may not be related linearly. However, we sometimes just check the linearity in the correlation. So we use the analysis of variance, or ANOVA and MANOVA, to determine the regression, so that we determine the linear regression coefficients in the data that we are analyzing. Let's move to the data analysis section in the next video. Welcome and thank you.